Alright guys, in this video we will communicate with two microcontrollers using I2C communication protocol. Here we will create new projects and select the board we are using. I'm using F44RE. Give the project name and click finish. I will clear all pinouts. First of all, I will set the clock. I will choose crystal oscillator and I will run my system clock at 84 MHz. I will choose I2C1. I prefer changing these pins from default pin to alternative pins. Although you can leave it on default pins, it will also work well. I will leave the parameter settings as default. Then check the interrupt table and add the TX to transmit data with DMA. I will configure the PA5 as output to toggle the LED. That's all here. Save to generate our code. I will define the slave address here. This should be 7-bit address. This is 27 hex shifted left by 1. Here I will define the variable, the buffer that we hold the data we will send to the slave. We will send hello to the slave. Hello from master. Here we will send the data to the slave. Choose this for the polling mode. The I2C handle the slave address, the buffer that contains the data we are sending, the size of the buffer, and the timeout. If the master does not send the data within this timeout, it will report as NAC. Build the code. It builds successful. Here we will create another project for the slave, the same way we did for the master. Here I will set the serial wire debug and configure my clock as well. Set it the same way as masters. Here I will set the slave address here. You have to set the slave address here in the parameter settings. I will set 27 hex. Remember, this is the slave code. Add RX to receive in DMA mode. I will change my pins as well. And configure PA5 as output so we can toggle the LED. That's all in slave code. Save to generate our code. I will define the buffer that will contain the data we will receive from the master. 50 addresses. Here we will receive from the master the I2C handle, the buffer we created above, the size of the buffer, and the timeout as well, as we are receiving in polling mode. So here in the master code, we delay a little bit here. We add delay here, 100 milliseconds. So build the code. It builds successful. Build the master code as well. Successful. So here we will print. After we receive the data, we will print something on the screen. For us to print, we will add a header file. So go to the slave code, the slave project, to modify the system call so we can be able to print something on the screen. You go to system call, file, and modify it. First of all, we include the header file here. The header file for F4 series. Then go to the write function to modify it. Comment on this function and modify it. Copy it. Modify the function. Modify it this way. So run the master's code if you are using the same PC for the both projects. Run the master code, run it, and debug the slave code. This is slave code, we debug it. Click here, double click that place, then the slave code will come out. Then select the ST link of the slave board. Don't forget to check the serial wire view before debug, then debug. We will add our RS data here, so we can view the data received from the master. We'll add the variable here, so we can view the data received from the master. So here, if you can bring this out, the console, the ITM console, go to the window, show view, SW view, then bring the ITM data console. So click on it, then go to the settings, enable this, and click OK. Shift this printf. Now we can receive the data here. We have received the data. The slave have received the hello from master. As you can see, the print is working well. The printf is working fine. Data received. So your board, you can set up your board, the data line of slave to the data line of the master, the same thing as clock, the ground of both boards together, and use 4.7 kilo ohms to pull up the data line and the clock line. Connect the resistors to 3.3 volt, then connect it to the data line and the clock line. To pull it up, you must pull it up, otherwise it will not work. So you can check the pinout of the board, of your board. You can check the pinout. So now we are going to do the same using transmitting data in interrupt mode as well. So here we will change this to IT interrupt to transmit in interrupt mode. It's just the same thing, just change it to transmit IT. Fill all the arguments. So here we're going to call the callback function. We are going to set the callback function here. When the master transmit the data to the slave, when it's finished transmitting the data, this function here will be called. And anything inside the function will be executed. So in this function, we are going to toggle our LED on the master board. So here in slave code, we are going to listen when the master initiates any communication. The slave will listen if master have initiated any communication. Once it sends any communication, it will now check if the master is calling its address. So we are going to write the address function here. Once the master initiates any communication, then the slave will check if master is calling its address. Once master calls its address, this function here will be called. So when the function is called, when this function is called, it will also check if the master is requesting for data transmission or reception. So here we said if the communication is transmission, if it is I2C direction transmit, which means the master is about to send the slave to slave, is about to send to slave, then the slave will receive the data from the master. So here we will call slave sequence receive, IT, to receive the data in interrupt mode from the master. We can receive multiple chunk of data with this function here, but here we will receive this data as first and last data. So here, when the communication is done, when the slave finishes receiving the data from the master, here we are going to turn on the LED on the slave board to show that yes, we have the data now, the communication is done. This function is telling us that the slave have received the data from the master. So it returned the LED on. So if the slave received the data from the master, it will listen again for another data. We will put the printf inside that function. So after it received the data from the master, it will print something on the screen, then listen again. So build our code. We have some warnings. We add the void here. The function is void function. It's not returning anything. So it builds successful. Change this function. Change it to L instead of I. So here in the master code, we will change what we wrote before. First of all, declare this variable here, the count variable. So we will increment the variable here. If the variable count to 2, it will reset back to 0. Then here, we will put here, if the variable count 1, let it toggle our LED on the master board, because we want the LED to be toggled. So it will be done in while loop. We'll put delay of 100 milliseconds. Then build our code. Run the code of the master. Run it. Then debug the code of the slave. Here now, we will receive data from the master in interrupt mode. Polling mode is receiving when you use a polling mode, the CPU is the one handling the data. But when you are using the interrupt mode, when the data is received, interrupt will generate and tell CPU that yes, the data is received. But DMA does not involve CPU. The data goes straight to the memory, and DMA is most efficient. So here we do the same thing using DMA mode. Just change this to transmit DMA. We don't need this anymore. So it's the same thing. Build the master code, go to the slave code and modify this function here to receive in DMA mode. You run the master code. If you are using the same PC for the two projects, run the master code and debug the slave code. So now we have received our data in DMA mode and the printf is working fine. Our code is working as expected. So here is our board. As you can see, it is working as expected. Don't forget to subscribe to our channel. This is it for this video. Thank you for watching. Bye.